All right, so guys, we're in lesson 6. This is page, I don't know, 23 in your packet. But your do now for today was to check over your answers from yesterday's work. This would be on page 21. Page, come on, 21. All right, so number 1, it says corresponding angles. So corresponding angles slide onto each other. So one of the relationships is angle 1 and angle 5. You can see that if you slid that down along the transversal line, you'd have corresponding angles. There are going to be 4 pairs, 2 and 6, 3 and 7, 4 and 8 as well. All right, then it says identify all the pairs of alternate interior angles. Well, alternate means on opposite sides and inside the parallel line. So one example would be 3 and 6. The other example is 4 and 5. All right, so how do we know that 1 and 8, let me erase this. How do we know that angle 1 and angle 8 are going to be congruent to each other? What is their relationship? Well, I can see that they're on opposite sides of the transversal line, and they're outside the parallel line, so that's alternate exterior angles. And if angle 4 is 73 degrees, I know angle 8 is also going to be 73 degrees because the relationship between those two angles is corresponding. If angle 3 is 107 degrees, then I can assume that angle 6 is also 107 degrees. And there's a couple things I can look at. I can see that they're both obtuse angles, and they're going to be congruent to each other because of alternate interior angles. Right. So angle 2 and angle 7 are congruent because of alternate exterior angles. And if the lines are not parallel, you cannot have these relationships. You can only have these relationships with parallel lines. So now we're looking at the situation for angle 1 and angle 5. So we have to know, are they congruent to each other or are they supplementary? So if we look back at our picture, angle 1 and angle 5 are corresponding angles. So they're going to be congruent to each other. So this would be the correct answer, A. And then 4 and 5, if we look at the relationship between angle 4 and angle 5, they're alternate interior angles. So that's going to put the situation where part equals part. And this E should be an I, my bad. All right. We're going to watch a quick video within a video, which is always fun, on what we're learning today.
Applying the Pythagorean theorem. The Pythagorean theorem states that the measure of 2 legs of a right triangle squared and added together equals the square of the hypotenuse. The Pythagorean theorem helps people solve real-world problems. Lucy usually bikes to the park along Maple Avenue, then up Silver Street. Is Canyon Trail shorter? She knows the 2 legs, Maple Avenue and Silver Street, are 3 and 4 miles long. Applying the Pythagorean theorem, 3 squared plus 4 squared equals 25. She knows that 5 squared is 25. So the hypotenuse, the length of Canyon Trail, is 5 miles. 2 miles less of biking for Lucy. What if Lucy doesn't know the lengths of Maple Avenue and Silver Street? A coordinate plane can help. Lucy's house and the park can be points on the plane. One at 5, 1, and the other at 2, 5. To find the distance between A and B using the Pythagorean theorem, she needs a right triangle. One way to make one is to go 3 spaces left and 4 spaces up. For the horizontal leg, take the x distance of A and subtract the x distance of B. This is equivalent to subtracting the x coordinates of A and B. For the vertical leg, take the y distance of A and subtract the y distance of B. This is equivalent to subtracting the y coordinates of A and B. Now apply the Pythagorean theorem. 4 squared plus 3 squared is equal to 16 plus 9, which when added together equals 25. That's the same as 5 squared. Again, the length of Canyon Trail is 5 miles. If you can represent a problem using a right triangle, the Pythagorean theorem can help you find distances.
Beautiful. All right, so that's what we're learning today, is we're going to be using the Pythagorean theorem.
I want to know, is there a quick way, rather than me drawing every single triangle, right? Is there a
Dude, this is gonna be
faster way
awesome.
to work out this relation?
All right, so that was some weird guy, but we're back to normal now. So what we're going to do is I'm going to model the steps for you, and then you're going to do an activity in your groups in a simultaneous round table. So the first thing you're going to do is write the formula a squared plus b squared equals c squared. So whoever the first person is, they're going to do that. Then you're going to check to make sure they wrote the formula correctly. And then the second player is going to substitute values. So in this case, we know that one of the values is a, the other leg is 7, and we know the hypotenuse is 12. So this is C, A stays A, and B is 7. Now I'm going to work, player 3 is going to make sure that that was written correctly and work it out. A squared stays, because we don't know what A is. 49 is 7 squared, and then 12 squared is 144. You subtract 49 in this case, and you get a squared is 95. And now the square root is the last step. Take the square root of 95, and you get 9.75. So that means A is 9.75, which makes sense because that is the longer leg, and the shorter leg is B. So you're going to need to see me if you're not here today to get the practice problems for this problem. All right. Here are the answers to 1 through 4. Or here are the questions, excuse me, for 1 through 4. So you're going to write the formula on the paper, pass it to player number 2. Player number 2 is going to substitute the values. Player number 3 is going to solve the equation, pass it to number 4, and then player 4 is going to check to make sure all the work was done correctly and start the next problem. So these are 4 problems you need to do on a separate sheet of paper. All right, now that we know the Pythagorean theorem, we can now use it in Euclidean geometry to figure out how far 2 points are away from each other. So let's go ahead and work this problem out. First step is to draw 2 points. And now we're back on page 23 in your packet. All right, so we're going to draw the point 0, 0, and 3, 4. And we want to know the distance between them. We can't just count the grid lines because it's a diagonal line. So we're going to call 0, 0, x1, y1, and 3, 4, x2, y2. Now we're going to create our right triangle. And it doesn't matter which way you draw it. And we're going to label this C, or you can call it D for distance. And we're going to label the legs. This would be A and B. In this case, B equals 3 and A equals 4. So then the next step is to use the Pythagorean theorem, which is a squared plus b squared equals c squared. So 4 squared plus 3 squared equals 16 plus 9, which is 25. And the last step to figure out what c is, you take the square root of 25, which equals 5. So c equals 5. The other option is to use the distance formula. So the distance formula is basically doing all this work except without a coordinate grid. So to find the distance, the last step is to take the square root. So that's where this comes from. Now to get A and B, what you essentially did for A is subtract the y values. So this y value was 4, and this y value was 0, so 4 minus 0 is 4. To get B, what you did was subtract your x values. This x value was 0, this x value was 3, 3 minus 0 equals 3. And so the distance formula looks confusing, but really it's not. You just take x2 minus x1, square it, and then add it to y2 minus y1 and square it. So it's doing the same thing. It's just if you don't have the grid to draw the right triangle to count the squares, you subtract the coordinates to figure them out. So in this case, it would have been 3 minus 0 squared plus 4 minus 0 squared. And then you take the square root of that, and you'll see that it's the square root of 9 plus 16, which is the square root of 25, which means 5. So you end up with the same answer. We're going to go ahead and practice this in our groups. This is on page 24 at the top. There are 2 problems that you're going to do. Example 1 and example 2. Player B is going to work the problem number 1, and player A is going to coach them through it. Player A is going to work the second problem, and B is going to coach them through it. Please make sure you're watching the person as they work the problem so that you can check to make sure that they're doing everything correctly. Don't both of y'all work independently and then check your answers later. So this is player B's problem, and then the second one is player A. All right, we'll check our answers momentarily. The second formula we're going to learn today is called the midpoint formula. You're going to need to know this. It's on I think every test that you take in here for this whole unit. So we're basically going to be trying to figure out the exact middle. So if we have this line AB, we want to know this middle point right here, the point that bisects the line into 2 equal parts. So if we're given these endpoints, basically you're just going to take x1, y1, x2, y2, and plug them into the formula. You're going to add your x's, divided by 2. You're going to add your y's, divide by 2. And what you should notice is you're going to end up with a coordinate pair. So 1 plus negative 3, well that's negative 2, divided by 2 is negative 1. 2 plus 5 is 7. 7 divided by 2 is 3.5. Yes, it's okay to get decimals. That's always an okay situation. So the midpoint of this line right here is at negative 1, comma 3.5. So let's look at a second example. Let's look at this line TS. Again, you're going to label your points x1, y1, x2, y2. So it'll be negative 2 plus 2 divided by 2, negative 5 plus negative 1 divided by 2. Your answer is always going to be a coordinate point. This is 0 divided by 2, which is 0. This is negative 6 divided by 2, which is negative 3. All right. Your work for today is on page 25. Which is right there.
Deputy Sellers, Timothy McCready, please come to the main office. Deputy Sellers,
25.
Timothy McCready.
You need to complete all the problems on page 25. And let's go ahead quickly. What if we have a midpoint and an endpoint? Then how do we find our final point? So let's say we're given this point here at A, and the midpoint, we want to know what the coordinates of B are. Well, this you're just going to have to use some deductive reasoning. How do you get from negative 3 to 4? Well, you add 7. So you're going to take 4 and add 7, which is 11. And then here, how do you get from negative 5 to negative 9? You subtract 4. So now you're going to go from here and subtract 4 more, and 9 minus 4 is negative 13. So you're just kind of working backwards. So go ahead and read through this, try this example, and as you work it out, you should get 0, negative 8 as your answer. But go ahead and pause, make sure you know it, and then you go ahead and start your work on page 25. Your exit ticket, as always, is on quizzes.